Welcome, dear students, in our series of lectures on no drug delivery systems. I am Dr. Ajay Similty from Garhwal University, again with you. We have discussed the concept of Ndds, targeting, and then we were moving to the polymers, and then we took the pulmonary drug delivery systems. Now, we are going to discuss the third part of the pulmonary drug delivery system lecture. In this lecture, we are going to discuss the components, rest of the components and systems of aerosols. Okay. Let's see what we are going to cover and what you are going to learn from this lecture. Learning outcome. After completing this module, you will be able to know about the construction of aerosol, understand the different systems of aerosol and discuss manufacturing of an aerosol. We will be covering this lecture under the heads valve and actuators, various aerosol systems, different types of systems, and their manufacturing. Now, what are the components of aerosol? We discussed, as far as the components are concerned, there are four major components. What are those four major components? Propellants, which is in heart of an aerosol package. Second is container, different types of containers like aluminum, SS, plastic, glass, we have covered in the last lecture. So two components we have discussed in the last lecture, and next two components we are going to discuss here along with the system. So what are those? Valve and actuator and product concentrate. Now valve. Valve is a vital component of an aerosol package. Actually, it is the component which governs the delivery and performance of an aerosol system. That's why it has got the vital importance. Now, let's see the functions. Looking awkward? No. It is the way we are going to learn these functions. RPG. R stands for regulating the flow of product out of the container. P stands for providing discharge of desired amount when needed and preventing loss when not in use. And G, governing the characteristics of dispensed product. So let's see it. RPG, R, regulating the flow of product. P, providing discharge of desired amount. And G, governing the characteristic of the dispensed product. So these are the three major functions which a valve does. So remember this thing. The valves may be continuous or metering. Continuous spray valve or it may be a metering valve. Now, what is the continuous spray valve? They are needed for high speed production and dispensing. Spray continues till the pressure is maintained on the actuator. You might have seen your DO sprays. So the kind of valve which provide the continuous spray till you have given the pressure on it, it will be called as a continuous spray valve. Okay, it means there is no mechanism of measuring an amount which is going outside. Okay, because the amount or the continuous spray depends on the pressure timings onto the valve. Metering valve, as the name suggests, it delivers a certain fixed amount, measured amount, ranging from 25 to 150 microliter for inhalation aerosols, up to 5 ml in the case of topical aerosols. It is required for potent medication where the doses are very crucial. Okay. A metering chamber is the integral part of its design. A valve is there, but a metering chamber is there in which fills first and then only that much drug is delivered. Okay. So it is called metering valve. The component valve, as you can see in this figure, from top you can see that the orifice insert is there from where the discharge happens. Actuator is there, it's an assembly, then stem, gasket, valve cup, spring, spring valve housing, in which all these are there from stem to spring. Okay, and then last is the dip tube. So these are the major you can say parts of the valve, components of the valve. Let's take them one by one. Valve cup, the upper part, that mounting cap, is called ferrule. It is used to attach the valve properly to the container. Maybe um, it's generally made by the tin plated steel or aluminum. Then comes outer gasket. It is the seal between the valve cup and the aerosol can. Okay? It is providing the attachment. Valve housing. This valve housing is generally made of nylon or Delrin. Opening at the point of attachment of the dip tube. At the attachment of dip tube is generally 0.31 inch, 0.13 inch to 0.08 inch in diameter. Sometimes vapor tap may also be there. What is vapor tap? Vapor tap is provision of providing or preventing the clogging, and it helps in satisfactory dispensing, and it decreases the chilling effect of propellant on skin and prevents the flame extension. So the valve body contains the valve stem, spring and inner gasket. So the entire valve housing is called valve body, in which you will have valve stem, spring and inner gasket. Okay. Now dip tube is there. Dip tube you might have seen in your, even in the, you are using your liquid soaps, the tube which is dipped into the particular body of the medicament or maybe the liquid into the can is called dip tube. This dip tube gives the way to liquid to enter into the valve. It takes the liquid from the bulb to the valve and dispense it, and helps in taking it. Only dispensing is the work of valve, and it allows and ensures good mix of propellants with drug concentrate, so no propellant can be dispensed without drug. So actually it is ensuring that not only propellant is going alone, but the drug is also there with the propellant. So it ensures the delivery of drug along with the propellant. Okay. It is generally 0.12 inch in internal diameter, and for viscous product the diameter may be somewhat more, ranging to 0.195 inch. Okay. These diameters are asked in GPAT examinations. Okay. Actuators. It helps in releasing the contents from a pressurized container. It is upper part, as you can see in the figure. The upper red part is the actuator. It fits onto the valve stem. It governs the type of delivery, fine mist, wet spray, semi-solid stream. All these types are governed by the type of actuator you are using in an aerosol system. Spray actuators, foam actuator, solid steam actuator, mechanical breakup actuator. So depending on the type of product desired, type of delivery desired, the actuators may vary. Now moving to the fourth component, that is we have studied all three components. Now we are moving to the product concentrate. What is the product concentrate? Product concentrate is basically one or more APIs put together, which are called API mix. Then solvent is there, surfactants, antioxidants. So product concentrate involves, along with the drug, these components. Okay. So first was our this propellant, then in this container, third valve mechanism, and fourth is the product concentrate. Okay. Now let's have a quick recap. Their valve may be continuous or metering. The third component, valve cup, gasket, Ball body, dip tube and actuators and the components are the components of the ball body. Product concentrate is a good mix of API with other ingredients. Now we will move to the types of aerosol systems. Here is the classification of aerosol systems. When the basis is propellant or container based, you can classify it, the aerosol system, into three classes: liquefied gas system, compressed gas system and barrier type system. LG, CG and barrier type system. When you classify them in dosage form based, then they may be solution, suspension or dispersion and emulsion system. So there are again three types: solution, suspension, emulsion. Now let us take the liquefied gas system. We have discussed the liquefied gas propellants in our discussion, in the opening discussion of the propellants. Liquefied gas propellants are used here. Boiling point, their boiling point is less than 21 degrees Celsius. Vapor pressure is of 13.4 to 135 psia at 21 degrees Celsius. And pressure on liquid phase pushes the product, concentrate and propellant up in the dip tube and disperse due to the large expansion in atmospheric pressure. And what is the utmost important thing? That final pressure is equal to the initial pressure throughout the shelf life, as we have discussed in the liquefied gas system, liquefied gas propellant section. Okay, so this is the point to be addressed. Liquefied gas systems, they may be of two types: two-phase systems and three-phase system. In the two-phase systems, space spray, surface coating spray may be there. In three-phase system, aquazole, foam system may be there. The two-phase system, let's take the solution system first. This is the solution of API in pure propellant or a blend of propellant and solvents. It is easy to formulate if no solubility problem is there, and problem is it is prone to chemical degradation. Just only one problem there. Let's take the general formula for solution system. The API you can take from 10 to 15 weight percent, and propellant of, say for example, you are using 12 and 11 propellant. Remember the 3-digit system, it means in 12 it is actually it is 0 1 2 0. Okay, it is 3-digit system in which first digit is 0, then it will be a 2-digit system only. In system is 3-digit, but if it is 2-digit, it means the first digit is 0. So propellant 12 and propellant 11 in the ratio of 50-50 up to 100%. Two-phase systems, suspension or dispersion system. In the two-phase system, let's take the another one that it is required to deliver the insoluble drugs, because suspension are the dispersion of insoluble drug into the another media. To deliver higher doses, suspension or dispersion systems are used. Constant agitation is required during manufacturing of these system-based aerosols, but they are prone to physical instability, which is the common feature of which is the common problem with the suspension, like agglomeration, caking, particle size growth, and due to them wall clogging or closing is there in aerosols or pulmonary target systems. Another example of this category of general formula we are giving, please see that API is 0.5 to 1%. See, the amount is less. Sorbitol triolate STO 0.5% and propellant 12 and 114 in the ratio of 49.5 to 49.5 to 100%. Okay. Now, improving the solubility of aerosol systems. What we can do to improve the stability of an aerosol system? First, we have to lower the moisture content of the preparation below 300 ppm. We must use, if stability problem is there, API's derivative, which is more stable. Use the more stable derivative of API rather than the parent API, which is not much stable. Then product particle size should be less than 5 micron or 50 to 100 micron for topical aerosols. Adjust the density of propellant and or suspenoid so that it is stable one. And practice use of dispersing agents like surfactants with HLB less than 10. For example, sorbitol trioleate, STO, sorbitol monoleate, SMO, isopropyl myristate, IPM and mineral oil. So we can use these surfactants which are having the HLB value less than 1 to stabilize this system. Okay. So moisture content, lower the moisture content, API derivatives and reducing the particle. So the aerosol may be classified in different systems. Just having a quick recap of the things that they may be classified in different systems, and this classification is very important with respect to your exam point of view. So whenever the aerosol systems are asked, their formation asked, you must give the two different types of classification. Okay, propellant based systems like three-phase system, two-phase system, or the dosage form based systems, propellant container based systems, and liquefied gas system. It may be of two or three phase system, and system stability must be focused in aerosol, specifically with suspension type systems. So classification is very important to learn when you are going for preparation of your examinations. Okay. Now three phase water based systems, liquid components which are not miscible with propellants can be used more in this system. In this system, low percent of propellants are used, and for these systems, special type of actuators like mechanical breakup actuators are used. This is asked in the examination, where mechanical breakup actuator you will use. Three-phase water-based system. Okay. Three-phase water-based systems, uh, what are the three phases actually there? Number one, vaporized propellant. Number two, liquid propellant. And number three, aqueous solution of product. As you know these three phases, the mixing of the drug in the propellant system, whether the liquid or in the vapor, is very crucial in these three phases water-based systems. Take this example of the general formula: API 40 to 85%, surfactant 0.5 to 2%, and propellant to 5 to 10%. So as you can see that much more quantity of API you can load here as compared to other systems. Okay. Now foam or emulsion system. Emulsified propellants, it is whenever foam is there, it means emulsion is formed. One, now the propellant is propellant is emulsified here. Okay, as you can see, you use your shaving foams. These are actually the uh, foam type system, foam type aerosols. Okay, suitable for topical aerosols. It is they are used at 40 to 50 psig at 21 degrees Celsius with 4 to 7% concentration. uh, OBW emulsion is there, oil and water emulsion. If propellant is in internal phase, okay, then foam type dispensing will be there. When you will prepare water and oil emulsion if product concentrate is in internal phase. So what kind of streaming will be there, what kind of dispensing will be there, wet stream dispensing will be there. So when you are preparing a O by W emulsion, foam type dispensing will be there, oil and water emulsion. And when you are preparing water and oil emulsion, when the product concentrate is in internal phase, the wet stream dispensing will be there. These are two important factors. Now moving to the compressed gas systems. They are used to dispense semi-solid, foam or spray discharge. An initial high pressure is required. We have discussed it in the propellant that initial high, because the pressure keeps on lowering when you deliver the drug through these systems. So initial high pressure of 9 to 200 PSIG at 21 degrees Celsius is required to maintain the pressure at the end of up to the end of this shelf life of this kind of system. Now moving to the barrier type system. As the name suggests, there is a barrier between the product and the propellant, or propellant are separated from product with some physical barrier. As you can see here, the pressure outside the barrier pushes the content from the container. It is like piston like system. A piston is moving there and it is throwing the drag or the API out of that container. They may be three types: piston type, plastic bag type, and canning can type. There are three barrier type systems. For semi-solid dispensing, piston types are used. Ointment, cake, decorating creams, piston type aerosol system are used. Plastic bag types are also used in providing stream, fine mist dispensing. In case of cream, ointment, gels, bakers use this kind of systems. Can in can type, nasal aerosols are there with aqueous solution of insulin. Now let us discuss how we will manufacture the aerosol. It is very important with respect to the exam point of view to address the manufacturing of aerosol. Two types, remember: pressure filling and cold filling. Pressure filling and cold filling. Now let's discuss pressure filling. We will not be discussing it in very much detail, but just to have the concept that pressure filling is just like you fill your LPG cylinders. They are filled in the companies there. Okay, the system are there in the line and they are filled with the pressure. What are the steps there? First of all, the product is chilled and chilled product concentrate is added to an open container. In the next step, the wall is crimped in place, wall is placed on it, and in the step 3, propellant is added under pressure through that wall. Through that wall, the propellant is added. Remember this thing. And then in the last step, the filled pack is passed through the water path, that is the leak test, and when it passes, the manufacturing is rendered to be completed. So this is called pressure filling. Now we will move to another type of manufacturing. But remember this thing, that you will have to chill the product first, then put the wall, then propellant, and then the leak test will be performed. This is the major process of the pressure filling manufacturing of aerosols. Now let us discuss the cold filling apparatus. In this step 1, product concentrate is cooled or freeze to -30 to -40 degrees Celsius. Cold concentrate is added to the chilled container in the step 2, and in step 3, propellant is added, wall is crimped in place, and then in the last step, the filled pack is passed through the water bath at 55 degrees Celsius for leak test. So these are some of the references which you can go through. Now let us summarize how we can learn the valve function. RPG, remember those things, these acronyms. Okay, regulating, providing, and governing. Remember, in the component of valve, that actuator, valve body, dip tube, all the components you must do, and that particular figure, the drawing of that particular entire valve, you must learn. Okay, together with the metering valve. Metering valve, however, we are going to discuss in detail. But you must know what is the design of metering valve. Metering chamber is there. Just remember, just learn the diagram of metering valve. It is many times asked. Okay, you might be asked, just draw the metering valve. What is the metering valve? So you will have to address that thing. So just that metering chamber is there. Apart from these things, the classification of aerosol system, the liquefied gas system, compressed gas system, and barrier type system. The liquefied is subclassified into 2 and 3 phase systems. Okay, All aerosol systems need stability, and for stability, ensuring what we have discussed, that keeping the motion content lower, particle size control, and the suspensionized system need utmost attention. So do what you can, what parameter you can control for stability of the uh, overall aerosol system. There are two techniques of manufacturing: pressure filling and cold filling. These are the two major methods of aerosol manufacturing. Now, refer the further text if you want to learn the things. We'll be addressing rest of the pulmonary drug release system part in our next lecture, and that would be concluding lecture of pulmonary drug release system, in which we are going to discuss that uh, how they are, how the propellants, how the overall aerosol systems are evaluated. Okay, how they are evaluated, and we will be discussing all the parameters, all the evaluations prescribed by the various pharmacopoeia. Okay, and we will be also discussing the major inhalers, MDIs, DPIs, okay, and nebulizers in our next lecture. So remember the things to learn the classification, to learn the function of wall, diagram of wall, and manufacturing technique for this lecture for your exam point of view. Thanks for being with us. We'll be back again with the concluding lecture of pulmonary drug system, in which we'll be discussing rest of the part of the evaluation. Thank you and happy learning.